Welcome back to Tools and Track, episode 3 of Dannykart. In the first one, we discussed the concept. In the second one, we discussed the principle. Now it's time to discuss the fun stuff, the hardware. Hardware is something I'm going to have to take a bit of a guess at, because whilst I understand what my concept needs to be to prove a reality, the hardware is really a complete stab in the dark. Now, remember, we're talking about version 1, so let's strip this all back to bare bones. What we're really doing here is making a full-size car remote control. Now, the first step to that is going to be a user interface. So how do we control the car without the normal steering wheel, brakes and pedals and such? PlayStation controller. I mean, this is literally turning a real car into a Gran Turismo simulator with some substantially increased risks, I'll grant you. But this guy should do perfectly fine. We've got accelerator, brake in analog format, left and right in analog format. So yes, we have other buttons and other functions, and if I'm feeling particularly bored or adventurous, we can make them work. But these 4 controls here, that's all I'm going to need for this to work. Now, I didn't cheap out here and buy a wired version when I know that everything is Bluetooth, but I don't actually need Bluetooth. Think about it, this is going to be sitting right into a control panel underneath the dashboard. Run it with a wire. That will reduce your risk of any disconnection, any battery problems you're going to have with this. I mean, why make it Bluetooth when it doesn't need to be? There's so many things in this day and age that I'm like, does this actually need to be Bluetooth? This definitely doesn't. Right, so this isn't also, I'll clarify, an actual PlayStation controller. It is a generic one, but it specifically does have these buttons as being analog. And that was one of the prime drivers behind it. I don't want a purely digital control, mainly because if you press the go button and you get full throttle, it would be damn hard for me to control it. I don't even want to think how it would be if you were using a straw to do it. Right, so that is phase 1. Where do we plug this into though? Well, what I did think about doing, and I did mention in the last episode, was using a Raspberry Pi. Now, as it would happen, I have spoke to many knowledgeable people, and many knowledgeable people have told me I'm off my rocker. So why are we not going with a Pi? Because a Pi will do what we want it to do, but it'll do many, many other things as well. So over the years, Raspberry Pi has been developed initially as an open source basic way of doing computing, but they've become, well, what's the word? Too good. So as a result, when you grow a product group like that, it ends up becoming more and more complex. Now that's great because it means you can use a Raspberry Pi to almost be a mini PC, and it can do all sorts of fancy things with video and excess programming and all the rest. But we don't want that. And the problem when you start dealing with all of these excess things is you start building in more problems. Now, one of the most crucial things about the Raspberry Pi that's now put me off it is the fact that it needs to boot up every time you turn it on. Now, that in itself brings issues because that's a lag time. Also, it's a risk because sometimes it may fail on a boot up. What's the answer? The Arduino. Right, so this is what's called an Arduino Mega. Now there are obviously simpler versions, and I know I'm guilty of doing exactly what I said I didn't want to do with the Raspberry Pi. However, if I need to simplify this, I can prove the concept on the big boy, which has more functionality for idiots like me that don't know what they're doing, and then simplify for the final version. So what, I hear you all ask, especially those like me who are mechanical types, does this do? Well, quite simply put, it's got a little processor in the middle, this little square bit. It's got an input to program it and an input for power. Everything else is more or less an input and output controller. It's just a glorified logic gate. Well, to be honest, so is a computer, if we're being really blunt. But what it does allow me to do is take a range of predefined inputs, whether they be analog or digital, and put out a predefined range of outputs, whether they are digital or, if you look very closely, PWM. Now remember from the last chat, we were going to look to do PWM controlled servos. So this is actually perfect. Now, you'll note that much like me, it goes from 1 to 13. And I thought, oh, the servo's got 3 wires. I don't know, don't worry, it'll run 13 servos. So this is more than capable of doing what we need to do. Like I say, I've done a bit of research, but realistically, the sum total of my knowledge for how to make this work is computer, turn on.
Just use the keyboard.
But not to worry, we'll get to computers in due course. The last thing I had to buy, because when you're doing a project, you've got to have a spending spree, is the servos. So I had discussed these in a wee bit of detail in the last video, but this is what this guy looks like. Now you'll see on the side it says 35 kilograms. I'm hoping that's not just optimistic fluff, because we're going to need at least that for the brakes, if not more. But if it needs more, I've got some solutions in the head for that one. So as you can see, it's got 3 wires. Now one of those feeds the PWM signal, one's a ground and one's a permanent live. Unfortunately for me, it's not a permanent live in the sense that it just takes 12 volts. These are really specific. Obviously they're precision instruments. It needs exactly 7.5 volts. Now that again is something we'll need to cross the bridge on. But you may ask yourself, Tommy, you are a mechanical grease monkey. How do you know all of this data about this stuff so early on in the project? Well, the simple answer is I have a technique for that too. And without giving too much away, there's a special principle you can use in engineering to solve problems. It's called cheating. Now, for years, I have always maintained that I am absolutely not going to do this, but I've got a big mountain to climb. And I will say that I've always stood on the shoulders of giants and used other people's learnings to help me push my projects along. It's the modern age, we're using modern tech. That's right, I've had to ask AI for some help. Let's be under no illusion, this is definitely the part of the project where I leave my comfort zone. Now, ChatGPT is sort of a kind of catch-all expression. I've used Microsoft Copilot for this, simply because it was the first one I found. I've got no affiliation to any of them. But in principle, it's an online artificial intelligence that basically uses the entirety of the internet as a way to answer all your questions. Sort of like Google on steroids, I guess, but it does form great descriptions on how to resolve things. We'll come back to forming great descriptions in a short second. Now, I've used it to sense check my idea, and I've kind of tailored some of my questions in a very special way. Now, first and foremost, what I haven't done is ask it to design me a car for a quadriplegic to use, because it's probably going to end up exploding into all sorts of weird and wonderful territory. The first question I asked was, I'm designing a tool that allows me to do X. Specifically, run 3 servos, or maybe 2 servos. Well, I've said 3 servos to begin with because I don't know how the steering is going to properly resolve. But basically, I want to do this. I want to run it with an Arduino, and then I also want to have an interface with a basic PlayStation controller. How do I do that? And that's where it got really scary. Because aside from telling me that I'm a very special and clever boy for starting such an impressive project, it then went to detail every single part of the BOM, the bill of materials, the list of stuff that I've already conjured up. So that actually validated my idea, which is good. It shows me I'm on the right path. But the scary thing with AI is what it does next. Instead of asking me what would I like to know next, it then suggests what I'm already thinking, such as, first up, would you like to know how to code that? Now, I don't know how to code that at all, and I've got to be honest, I was going to have to look for help on how to do it. But then, straight out of the blue, AI kicks out a whole line of code specific for an Arduino that, as far as I can work out, will actually do the function that I need it to do. So that's good. Copy and save. Then it goes into a bit more worrying detail. It then asks, would you like a wiring diagram? Well, golly gosh, I actually would. So it spits that out. Then it asks, would you like a termination diagram? And all of these other things. I had to get to a point where I was like, no, I'm sorry AI, I want to do some of this myself and actually learn it. See, this is the bit that worries me. It gets very, very easy to let AI do all the work. I'm pretty sure if I had a pair of hands, it probably would have actually soldered it all up and made the thing for me as well. But if anything is good to allow me a cross-check. Now, I don't trust the code. I don't think it's actually just doing anything else other than stealing other people's work. But the good thing is it presents it in a quick and easy to access way. Whilst I am buying all the parts because I'm sure from an engineering standpoint they'll work, I'm going to get the code double checked before it blows everything up. However, as a starter for 10, it's certainly saved a lot of time. So listen, we're doing cutting edge stuff, we might as well try cutting edge technology. But now that we've got AI to give us a wee cheaty head start, it's time for us to actually do a bench test. Now, bench test without the car, let me explain further. So bench testing is normally something that is not a literal, well, is it literal? It doesn't necessarily need a bench, but I actually will be using a bench to rig all this up and use for testing. Now, those who say I'm a hoarder, who's laughing now? This is an MX5 pedal box assembly. Now, it's not the same as what's going to be in Danny's, but it's going to work for just kind of giving a basic test. It's also going to work quite well for resistance checking and seeing what these servos can do. So this is a brake and accelerator. Remember, we're not using a clutch, so we don't need to worry about that. The interesting point though, is I took this out of breaker car very, very quickly. And one of the things I remember from taking it out of said breaker car was, I didn't really take much time to strip things, it was a very quick thing. How has the accelerator pedal ended up like this? One of life's little mysteries, but we'll obviously correct it. So the idea with this is I'm going to add extra springs to represent the load that's going to be fighting against for the servos in this. So we'll start kind of putting things out and laying out how this thing will look. It doesn't need to be exact. Obviously it's all going to be test wires we're using as well. So the runs will change once everything's finalised, but it's also a good point for me to start this and see what I've missed. So, and have the first montage of this series. Pedals. So now we have a layout of all of the wonderful things I've bought. We should probably have a run through of what they actually are, and as is it's me, tell you all what I forgot to buy. So first and foremost, the really obvious one is the Arduino. And I'm also going to have to do a bit of a sketch up to make this make sense, because my good God, this stuff's very small. So this little guy will take all of the feed in and all the feed out, but there's more to it than just feed in and feed out. As you'll note, there is a big printer size USB port on the side of this, and also a power port. Power port. Now don't worry, there is a bit of a manual on this, and you'll be surprised, if not shocked, to learn I've read it. So what we need to feed this Arduino is just 9 volts DC. Now that's handy because it does have a 5 to 12 volt range that we can work with. 12 volt is probably going to be okay if I feed it from the battery. The issue is the battery charges at slightly above 12 volts, and that might overpower it. So first up on the list for testing purposes, I'm going to put that as a to be continued stable 12 volt DC. Ultimately, we're not going to be running it in the car for the bench test, so I have got a 12 volt DC adapter. Fresh off the bolt this morning from probably China, but it just plugs in 240 volt AC to 12 volt DC adapter. Now, I have also considered, is that also going to be a bit of a problem? I've got another 9 volt DC adapter, which I'll probably hold off and use instead. That's going to be due tomorrow. So that, to begin with, will solve our power issues. Now, I should also stipulate that the other USB, the printer one, can also power up the board and make it function for programming. I don't fancy the idea of using that smaller USB in to use all of the power for the relays and such, which is why we went for a stable 12 volt DC. But we also have the ability for a COM cable and a backup 12 volt if we need to do the programming. So I've done a wee joint line across to do that, but I would say that we are probably always going to run a dedicated voltage input for this guy, just because of the amount of stuff it's going to have to run. So the other things on our list is the relays themselves. Now, as I mentioned, they will take a feed out from the Arduino from the PWM channels. Taking an example that will either run the accelerator or the brakes, you'll notice, yes, there is a signal wire, but there is also 2 other wires. Now, this is where it gets a bit more out of my wheelhouse, but just bear with me. You'll notice I've got a PWM signal wire that goes from the Arduino into the servo, obviously, but we also have a dedicated positive and a dedicated earth. Now, because of the way all of this fancy computer nonsense works, It all must share an earth to the Arduino so that it knows an earth is happening, I presume. There's probably a far more detailed explanation, but any component we make the Arduino operate must share the earth that the Arduino has. That will probably come in very useful later on. However, the plus, right, now, unlike the Arduino, which by the way runs a native 5 volts because it's a computer, the servos are slightly different. They run a native 7.5 volts and obviously will draw more current. So this is why they all come with different wires. Ultimately, I cannot use the Arduino to both function the servo and power the servo. It has to be on a separate thing. So the servos will need their own power supply. And as 7.5 volt DC is also something that's not going to come straight from the car, we're going to need a step down transformer. That is what this guy is. So quite simply put, we will input an amount of voltage into here, and you can probably just about make out there is a calibration set of things in the bottom. Now, I've not fully read the instruction manual for this, but it means that you can set it to exactly 7.5 volts, and that means that the voltage that you put out to all of your servos will be exactly what they require. Also, being that this is independent from the Arduino, that stops us having to deal with 5 volts up to 7.5. We just put a 12 volt supply in and let the servos deal with themselves. Which means we will need to consider that specifically on all of our wiring diagrams and our hookup when we're doing the bench test. Now, that pretty much covers it. Yeah? No? Well, no, we've not even talked about a single input. And this is where I've already started to deviate from the original plan, which was using this guy. Now, from the start, I have always said, let's keep it simple. What is not simple about this is that there's about 15 different functions on it, and we only need 2 of them. So in an effort to make things as simple as possible, and bearing in mind that working with Arduino based equipment, we can use an Arduino based joystick. And that looks a little bit like this. As it happens, I could run the entire function of the car from this, which would be forward, brake, left and right. It's probably going to be better I split that into 2, because if we do end up using this for the actual function of the car, using your thumb to control the whole car is probably trickier than using 2 thumbs. So we will try and split that out. But you will note that there are 5 inputs on the bottom here. Funnily enough, ground is the top one. Remember what I said about a shared ground. We also have a 5 volt in, dedicated power. Great, the Arduino can power this without having to deal with any other transformers. We've got VRX and VRY. That is literally X and Y, 2 different signals. And then an SW. I don't know, we'll work that one out. But this is pretty Bobby basic, which means, if only for the purposes of a bench test, we do have a way to test it all in one go. So, what's the last bit of weird fancy electronics? Well, I got a bit carried away, right? Because I did say that we were going to use an Arduino, but that was only after I spent the sum total of about 6 quid on a Raspberry Pi Pico, which is basically the entry level, very basic, and by the way, look at it, it's very basic Raspberry Pi setup. And that also comes with a breakout board so that we can actually easier run inputs and outputs to it and set it on like that. It just clips in the top. Yeah, we're going to take this off the table. It's just going to confuse things, but it means that if I make this work and we have other ideas, there's a wee Raspberry Pi sitting there, a little bonus. Anyway, those eagle-eyed types will notice that we are missing 2 further servos off the back of this. Now I did have 3 servos sitting in the board, so first disclaimer of what not to buy would be this 3rd one. Now I looked up the specs and I was fairly sure what I ordered would do, which is basically an infinite rotation left and right servo, so it can keep going that way or keep going that way. And then the post is also a wee brass gear that would drive another gear, and this would actually sit on the steering shaft and turn it. But I don't think it's going to do that. I'm going to hook it up and test it and see if it is capable of going beyond, but the fact that very clearly on the datasheet and on the side of it, it says 180 degrees, means that I probably bought the wrong thing. Also, I'm just not convinced that this is going to be the steering solution. A, it is quite convoluted, and B, I just don't see that turning a steering wheel. I could be wrong, but for the moment, we'll come back to it. Well, TBC. But that doesn't matter, because for stage 1, which is the bench test, we have an idea of what we need to do. Now, we just need to make sure it all works. Now, what we don't want to do, because I don't want to let the smoke out of everything, is hook it all up, turn it on and see what happens. No, of course not, because that will end up just blowing something up and then I will get the rage face, and we don't want the rage face. Instead, what I'm going to do is calibrate this, the transformer. Like I said, that has to be powered up with nothing going to or from it, with no other programming, no other functioning for the Arduino to have to do, other than to make sure that that gets the thing. So we can do that. In fact, I think we can actually do that without plugging it into the Arduino. I need to go look at the manual on this more properly, but once we know by simply putting a multimeter across this and seeing what the input and output voltage is, that's set to 7.5, we've got a solution to run the servos. So I think we're not far away from a hookup and a test run. Right, that map over there is what I would like to refer to as a topological map. So basically, you see the outline and the rough idea, but there's no sat-nav associated with this. I couldn't put that in and go, right, that's exactly where every wire needs to go. It needs to be a street map. We need to be able to put in some navigation, which means my wires and my ports will all need a clearer definition, and I will then be able to sense check that on the board before we toss a single wire into anything. So in the next episode, that's what I will start with. The proper map as I see the way it should go. And then once we do that, well, we bench test. Anyway, I've got a few bits of business to deal with just before we wrap up. Now, the first order of business is patreon.com/toolsandtrack. Basically, everybody that's running up the side of the screen right now. Now, these guys have supported me during the low-cost build, and ultimately, it has paid for all of that. Now, if you've just joined, you don't know what the low-cost build is, obviously go and have a look. But fundamentally, that is still ongoing and you guys are still supporting me. It was going to support through the IVA, but I think this is a far more worthwhile cause. So henceforth, anyone who joins the Patreon, the funds for that are going to be going into the Dannykart, which is now, as far as I can work out, the best name for it. I was trying to think of something better, so if you want to hit me something up in the comments for what to call this project. Dannykart seems to be in the lead, but I'm open to ideas. If you guys have got something better, let me know. If you want to help, that's probably going to be the simplest way. Chuck us in, even if it's just for a month, and you know, it's not expensive. Every little helps, as they say. Similarly, since putting the last episode out, I've not had anyone come forward with a C3 automatic gearbox for a 4 Pinto. Again, mad plea, if anyone has anything like that lying about, or they know somebody that does, just go to please reach out, because I haven't really considered how difficult these are now to find, because presumably they've all ended up in the scrap pile. Last of all, in the next episode, understandably, let's do less whiteboard and more actual practical stuff. I'm going to go and aim to get a bench test on all of the stuff that we have ordered, and hopefully we might see a servo or two move. So that'd be positive. Until then, listen, if you just found this, thanks very much. Like, bell and subscribe, because that's the YouTube thing and nobody really seems to do it. Please be one of the people that does. And until next weekend, guys, drive safe.